Alright, so let's take a look on the day 7 practice here. So today will be the last problems on the Newton's laws and also kinematics. So we are going to look at a few more harder problems. So due to the problems are going to be harder, there will be also less calculation involved. Let's take a look on the first one. So for the first problem here, we know that a 2 kilograms box is originally at rest on a horizontal surface, where the coefficient of the static friction between the box and the surface is denoted as mu. And the coefficient of the kinetic friction between the box and the surface will be 90% of that previous coefficient. And then we have an external horizontal force of the P is applied to the box, and we want to see which of the following is a graph of the acceleration of the box versus the external force of the P. Okay, so first of all, we know that when the object is at rest, the force is going to be like the friction is going to be the static friction. So if you have the P here to be less than the mass multiplied by this friction here, your friction is always equal to the P. And in this case, there will be no acceleration, right? Because the two forces will always cancel out each other. So at first, there must be no acceleration, and it's always 0 when the P is not large enough. So we can see that the choice E and D must be wrong, because they both like either just start from a positive acceleration or just has a positive acceleration once we have some forces. Okay, but what about AC and B then? So AC and B both reflect that the static friction is changed based on the magnitude of the force P, but you can see here for the C will be wrong, because when the object starts to move, it starts from the 0 here, whereas we know the kinetic friction is less than the static friction. So when the force P is equal to this static friction, we know the object is start to moving and the friction is going to drop. And as the result, there will be a positive net force, right? Because this guy here must be less than the static friction. So there must be a positive net force. So C will be wrong. However, this guy here is not equal to 0. This guy is only 0.9 times n multiplied by the kinematic coefficient, static coefficient here. So B will be wrong, because if you try to extend the line here, the intersection is actually at 0, representing that in this case, you only undergoes the force P and not any friction. So the B is also wrong. And the correct answer is only the choice A, because you still has some friction. So this acceleration is not going to be very large. Okay, so let's take a look on the second one here. So the second one is actually harder because you need to also know the circular motion. But if you also think about from your experience, this one is not very hard. So if you have a small bead slice from the rest along a wire that is shaped like a vertical uniform helix, so we can kind of see the graph will be going like this. Okay, and then which graph below shows the magnitude of the acceleration as a function of time? So first of all here, when you have like the object just over here, the acceleration is not going to be just 0 at first, because there will always be gravitational acceleration. So if you just know this fact already, you can eliminate the answer choice B and C already, because there will always be the gravitational acceleration. Okay, so what about A, D, and E? So at this moment here, you can kind of just use the process of elimination. So for the A will be wrong, because in this case, the acceleration is constant. So this will reflect when the object undergoes a free fall motion, when you only have the gravitational forces, which is not going to be true in this case, as you have a circular motions. So there will be, of course, the centripetal force, and then you will also have some other forces like the normal force and the other forces. So anyways, we know the choice A is also wrong just by process of elimination. So now you only have two choices left. if you have to pick one here, you have 50-50 chance to pick the right answer. But to solve this problem, you also need to know the centripetal force. Over here, this guy is proportional to the square root of the velocity. So if you know this fact here, you can see that as the bead slides from the rest along a wire here, it's undergoing the accelerating motions. So at first, there will be less acceleration because there will be some normal forces, and it's going to just go down from stationary. But then as the velocity gets larger and larger, it's going to have a larger centripetal force. So the net acceleration is also going to rise proportionally. So if you know that, you can also pick the right answer choice, D. But yeah, if you know the centripetal force, the problem here is going to be a lot easier. But if you have to guess, you can also choose between D and E, and then D will be more likely. Just try to imagine the movements.